All right, teens, the next video I decided to do was about volume and area bounded by curves, particularly because this comes up on both the AB and BC exams. So question 1 from 2007 on the AB exam, the question reads, let R be the region in the first quadrant and second quadrants bounded above by the graph of y equals 20 over 1 plus x squared, and bounded below by y equals 2. Cool. I know what those curves are now. I know that this is a calculator question because it's question 1, so I'm going to graph that in my calculator. And I'll draw an approximation here. So you have your xy axes. I have y equals 2. And I have y equals 20 over 1 plus x squared. All right, so we're looking at this is R. All right, so A is asking about the area of R. So area, we need to know what our x and y are because we want to add up all of these slices between here, pardon me, our x values for our integral. It's x1 to x2 of big R minus little r. So your outer curve minus your inner curve dx, since we're looking at dx as well. If the curves were given in a different way, we might define them differently. All right, so in this case, I want to figure what that value is out by setting these equal to each other. Again, this is a calculator problem, so you can do this without doing algebra. Once you want to find what those points are, you can use the functions in your calculator. The work we get from that is x is plus and minus 3. So those are x1 and x2. I'm going to go ahead and say area equals -3 to 3 of the integral. And then our outer curve is our curve that's above, our upper curve and our lower curve. So I have 20 over 1 plus x squared minus 2 dx. You can integrate this using trig sub if you're a BC student. I don't think that's a good use of your time. I suggest plugging this into your calculator, especially because you have a calculator. We find that this will equal 37.961 or 37.962. This is an AP problem, so you will definitely want to go up to the 3 decimal mark. All right, as far as scoring, you get 1 point for the bounds. So you get 1 point for this calculation as long as they're used correctly. All right, and then you have 1 point for the integrand, so the correct setup, not including the bounds, and then you have 1 point for your answer. So that's the College Board grading. All right, moving on to part B. Part B is find the volume of the solid generated when R is rotated about the x-axis. All right. Okay, so we're looking for the volume when we rotate this area about the x-axis. So I'm going to redraw that graph just so we can see what we need to look at with volume. Then we're rotating here. So I have a big circle and a little circle, which means I am adding up the area of these circles. So volume is going to be the integral of pi r squared dx because we are adding in the x direction. And that's going to be from x1 to x2. If you define x1 and x2 equal to 3 explicitly, you can just continue writing this so you don't have to keep writing the value. That's particularly helpful with values that suck. These are fine values. All right, so we're here. R is going to actually be 2r. So we're going to use that same expression, outer r and inner r, for this integral. So I have -3 to 3. I'm going to put that pi out front because it is a constant coefficient. And then I have 20 over 1 plus x squared minus 2 squared because it's our outer radius squared, so our big circle minus the area of our inner circle. That's how I like to think about it. Don't forget your dx, and that will give us 1,871.190. Plug that into your calculator. Don't do it by hand. You're going to be stuck and wasting your time. The AP grader points for this are 2 points for the integrand, so I would imagine 1 point for the outer radius, 1 point for the inner radius, and all the accoutrement of the pi and the dx. And then you have 1 point for that answer. All right, part C is the region of R is the base of a solid. For this solid, cross sections perpendicular to the x-axis are semicircles. Find the volume of this solid. Cool. I'm going to keep drawing a picture. I keep going back to pictures because that's just how I think about things. If this doesn't work for you, you also will be able to graph this on your calculator. Now, what I know, I'm going to switch to pencil here, is that this is the base of my semicircle, and then they're coming up like discs like that. Let me actually make it visible for you. So those are semicircle discs. What I need to do now is scooch that. All right, we're finding the volume with the cross section. So I need pen again. We're integrating semicircles, so it's pi over 2 from x1 to x2 of r squared dx. Now we have to figure out what the r is. The diameter of the semicircle is what's sitting on that part of the curve right now, so r is equal to the distance that you cannot see. Jesus Christ loves us all. All right, the distance between these. Cool. Plug that in. Wait, what did I forget? This is our diameter. R is diameter over 2, so you can choose to deal with that however you will. For me, I can just divide each term by 2, and I have that there. I also used to teach pre-algebra, so I'm used to using that arithmetic a little bit more comfortably. Great. We have pi over 2, negative 3 to 3 of 10 over 1 plus x squared minus 1 squared dx. Plug that into my calculator once again. I get that the answer is 174.268. Where do those points come from? We have a point from the integrand here, just choosing however you're simplifying, and a point there, and then a point for the answer, and that's 9 points.